Hello mathematicians, and welcome back to the quadratic formula, and today we're on the final piece, which is part 3. Yay! No more having to look at this monstrosity, but I'm sure you guys have been having fun. So with part 3, by the way, have this worksheet in front of you, we're going to be looking at irrational solutions, okay? So I'm going to put you right here. Irrational solutions. So you might be thinking, what's an irrational solution? Well, so far we've been dealing with rational solutions, okay? Rational solutions are numbers that we like looking at. It's numbers like 5 and -2. Sometimes it's fractions like 2 over 3. Or even some nicer looking decimals like 0.25, okay? Irrational solutions, which you can abbreviate with IRR, are numbers that are not so nice. So maybe it's a decimal that goes on very long, like 1, 2, 3, 5, 9, 2, 5, and it keeps going. Or it is radicals that do not break down very pretty. And that's what we're going to be focusing on today. So far, when you've done the quadratic formula, when you get to the point where you have a radical, it breaks down very nicely. So for example, the square root of 4 equals a 2. The square root of 9 equals 3. But let's show you what happens when we don't get a nice squared number, like the square root of 5, okay? Let's see, square root of 5. You see how that gives us a very long, scary number? That is 2.2367, and it keeps going. This one's an irrational solution because of it. It goes on forever. We don't like it. So we're going to be dealing with those guys. Now, since we can't get a nice number, we can reduce them so they look a little nicer. And that's what we're going to cover today. Now, to reduce them, you need two things. You need to know your square numbers, which I have very generously provided for you right here. So squared numbers are numbers that when you times them by themselves, it's the product of the two exact same numbers multiplied by itself. So 1 squared is 1 times 1, which gives us 1. 2 squared is 2 times 2, which gives us 4. 3 squared is 3 times 3, which gives us 9, and so on. If you don't know these perfect square numbers off the top of your head like me, because I'm just brilliant like that, you can have a multiplication chart in front of you. And your perfect square numbers are going to go right down the diagonal of it. You can also highlight them here. So to recap, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so forth. So all of these perfect square numbers, when you put them in the radical, they give you a nice pretty number. But if it is not a perfect square number and you put in the radical, you get a fraction, an irrational solution. So today we're going to be talking about breaking them down. So first step, you need to write down the factors of your number. So right here for this example, we have 24. So I'm going to write them down. So 1 and 24 makes 24. 2 times 12 makes 24. 3 and 8 makes 24. And 4 and 6 make 24. Now, I'm going to look at my factors and try to find out if there are any perfect squares here besides 1, okay? So, not counting 1, that's not a perfect square. Neither is 24, 2, 12, 3, 8, or 6. But 4 is a perfect square. It is 2 times 2. So, I'm going to rewrite my the number inside my radical using this perfect square. 24 is 4 times 6. And that's legal, right? 4 times 6 is 24. Now, another thing that's legal is that I can split radicals. So right here we're going to split. Or I guess it's actually the next step. So the radical of 4 times 6 can be split into two radicals. So now it's radical 4 times radical 6. That is perfectly legal and something you should remember from real numbers. Now, if we take a look at the square root of 4, this is a perfect square. And if we plug it into the calculator, we get that the square root of 4 is 2. Can we say the same for 6? No, we cannot. So my answer would be 2 times the radical of 6. And that is how you split it. That is how you reduce it. I'm sorry. Now, not all radicals can do this, but if some of them can, it's nice. Because 2 radical 6 looks much better than the radical 24, if you ask me. So let's go ahead and try one. Right here I have an example already set up for you. So right off the bat, we should notice that this is not equal to 0. It has a -2. So I'm going to move over the -2. I have -2, so I'm going to do the opposite and do +2, +2. On my right hand side, I have 2 plus -2, and that gives me 0, right? Because if I have 2 of something, they take away 2, I have nothing left. So now I can add my 2 to the left hand side. Next step, I have to identify A, B, and C. So A is 4, B is -7, and C is 2. Now, for the rest of the video, I'm going to go a little faster because you should know this by now. I have the formula written up here for you in case you need it. So I'm going to plug it in. So I have x equals -b, -7, plus or minus the square root of b squared, which is -7 squared, minus 4 times a, which is 4, times c, which is 2. And this is all dividing by 2 times a, which is 4 again. I'm going to simplify this. X equals a negative of a negative is a positive. So I have positive 7 now. Plus or minus the square root. I'm going to have to do some math over here. Well, I guess we already are doing math, but some calculator work. So I have 7 times 7. So that's 7 squared. That gives me 49. So 49. And then I have -4 times 4 times 2. And that gives me -32. Minus 32. All over 2 times 4, which is 8. Now I'm going to simplify it inside my radical. 49 minus 32. No. 49 minus 32 equals 17 all over 8. So now this is where I check if I can break down this radical, okay? So I'm going to do the square root of 17. So 17, and then I'm going to hit my square root button. This does not break down easily because this is not a perfect square, right? So I'm going to try to see if I can find any factors of 17. So step 1. Find factors of the number inside the radical. Number inside radical. So right here I'll do some of my math work. 17. I know 1 in 17 goes into 17 because that's always true for any number. Now I'm going to look at my multiplication chart and check if any number goes into 17. I'm going to look left and right, up and down, and I'm going to find that nothing goes into 17. So that means that 17 is prime. So step 2, if number is prime, which in this case it is, then I cannot break it down. cannot be broken down. Wait. So what do? We can't break it down. Well, we just have to take it as it is. So I continue with my two cases. So now I have x equals 7 plus the square root of 17. And I have x equals 7 minus the square root of 17 over 8. Since this is a square root, this is an irrational number, and this is rational, they are not like terms. I cannot combine them. So then these are my answers. Since I can't combine them, I can't add them and then divide them. You could stick them to the calculator, but you're going to get a really long, nasty decimal. So then we just leave it like this. As mathematicians, sometimes we have to give up and say, this is as far as I got. I tried my hardest. But what happens when we can break it down? Well, for that, I'll see you in the next video.